So we just covered a measure of central tendency known as the mean or average. Now we're going to talk about two other measures of central tendency for a numerical variable. When you have a numerical variable and you want to know sort of a snapshot summary of what the typical observation is, you can look at the mean, the median, or the mode. And now we're going to talk about the median, also known as the 50th percentile. The median is simply the middle number in a set of observations or data points. The median, as I mentioned, is also called the 50th percentile. It means exactly the same thing. So median, 50th percentile. If you have a set of n observations or data points, the mean is calculated slightly differently if you have an odd number versus an even number of data points or observations. If n is odd, meaning if you have an odd number of observations, the median is simply the middle number. If n is even, the median is the average of the two middle numbers. So here's an example. Suppose you have a set of observations of 5, 10, 43, 50, and 100. Then the median is simply that middle number, 43, because there are two observations below, 5 and 10, and there are two observations higher, 50 and 100. So in an odd number of observations, the median is the middle number. But suppose we have 5, 10, 43, and 50 as our set of observations or data points. Well, this is an even number of observations. So the median is simply the average of the two middle observations. So the two middle observations are 10 and 43, and then you take the average of that and you get 26.5. Now just to be clear, when we're calculating the median in both of these examples, what you first want to do is you want to order your values or observations from lowest to highest, and then look for the two middle numbers or the single middle number if you have an odd number of observations. Now having said that, typically we will use statistical software to calculate the median, especially when you have more than 5, 6, 7, or 8 observations. If you have 1,000 observations or 1,000,000 observations, the median is easily calculated using modern statistical software. The median, or the 50th percentile, has some advantages and disadvantages as a measure of central tendency. One of the advantages of the median is that it's not affected by the extreme values or outliers in a set of observations. So if you have an extreme value or an outlier, then the median is going to be more robust. It's not going to be as sensitive to those extreme values as the mean. Another nice property of the median is that intuitively it makes a lot of sense, because the median is simply that number in which half of the observations are lower and half of the observations are higher. There are some disadvantages. The main one is, it's not a true disadvantage, but it's a disadvantage in the sense that the median is relatively difficult to incorporate into other statistical models. So as we explore more ways of analyzing data, you will see that the mean is commonly used. The median isn't used as much, and one of the reasons is that the median is a little bit more difficult to include in more detailed statistical models. But having said that, one major advantage of the median, especially as opposed to the mean, is that it is robust to outliers. To put it another way, it is not sensitive to outlying values. So let's suppose we have, just to make this clear, we have this set of observations. We have 1, 2, 3, 4, and 5. So in this set of observations, if you want to find the median, you order the observations from lowest to highest, and then you find the middle value if the number of observations is odd, or you take the average of the two middle numbers if the number of observations is even. In this case, we have 5 data points or observations, so n is our sample size, and so the median is simply that middle number, 3. So we have 2 data points below, 2 data points above. Now, suppose, for example, that we have an outlier. Instead of 5, we're going to change that 5 to a 10. So the number of observations is the same. The values of 4 out of the 5 observations is the same. So we have values of 1, 2, 3, and 4. All we're doing is we're just making an outlier. Well, in this case, the median, the middle number, is still 3. So even though we've included an outlier in a data set, the median is still the same. Now, if you recall, the mean before was changed by that extreme value. And one of the reasons that the mean actually includes information on all data points, it's really incorporating 1, 2, 3, 4, and 10. The median is simply that middle number. So if you're trying to capture a measure of central tendency and you have, or you suspect you have outliers in your set of observations, the median is nice because it's robust to these extreme values. So let's look at our data set of popularity among elementary school kids. And we have these 4 ranking variables, these discrete numerical variables, and let's calculate the median for each. Now we're going to use statistical software. When you use statistical software, it'll just calculate it automatically, so you don't actually have to rank the variables or do any calculations. But in our statistical software, the median for the grades variable is 3. The median ranking for the sports variable, the importance of sports in terms of popularity among kids, is 2. So you can see that sports is, the middle number, it's as a measure of central tendency, it's ranked lower than sports. So sports is ranked higher, meaning the closer to 1, it's the most important attribute of popularity among these kids. If you look at looks, or being pretty, the median is 2, and for money, the median is 3. So we have these values of the median. Now let's compare the mean values with the median values. Both of these are measures of central tendency. We're trying to find the typical observation, the typical ranking for each of these attributes of popularity. So if we look at the mean, the most important quality for being popular, as expressed by these elementary school kids, is sports. So if you want to be popular according to the mean, do sports. But how about the median? Well, the least important is money, similar to the mean, then grades, then looks, and then sports. So you can see we have a very similar set of results. However, looks and sports, we get the same middle value. And that's because with the median, the values, since we have an odd number of observations, well, in this case we actually have an even number of observations, but typically the median will, in general, be a value that is, if your underlying variable is numerical and discrete, your median is going to be a counting number. That's not always the case, but in general it is. So the key point here is if you compare the mean with the median, we have similar findings. However, with the median, we don't really find a difference between looks and sports in terms of importance. With the mean, we do find a very slight difference. But overall, you see a similar pattern where if you want to be popular, kids will say you should do sports. Now, let's suppose in our data set that we had an error. Okay? And these errors actually do happen a fair amount of the time. So an error in this case occurred when some hapless data entry assistant put in this huge value for this looks variable. So just suppose for that first row, for I equals 1, for that first row, our research assistant just put in 999,999 instead of 4 for the looks variable. What will happen if we calculate the mean ranking and the median ranking for the looks variable? Well, the mean, and we would use statistical software for this, is now huge. Okay, the mean is now above 2,000. Right? Before it was about 2. So you see this huge increase based on this one data point. Keep in mind, there are 478 observations that are used to calculate the mean of the looks variable. But just changing one of those data points, one observation, inflates the mean enormously from 2 to roughly 2,000. But what happens if we calculate the median, or the 50th percentile of this looks variable? Well, the median is 2. So the median is unchanged. And the important point here is that the mean changed, but the median did not. And that's because the median is robust to outlying values or extreme values. Now, we've talked about the mean and the median. A common other measure that is usually kind of lumped in with measures of central tendency is something called the mode. Right? The mode is simply the most common or frequent value in a data set. So to calculate the mode, what you first want to do is you want to list the values from least to most frequent, and then that last value will be the mode. So typically, we will use statistical software to calculate the mode. Just like if you have a pretty large data set, you will use the statistical software to calculate the mean or the median. The mode has a few pros and cons. One advantage of the mode is that it is unaffected by extreme values in a similar way to the median. It's not going to be altered too much if you have an extreme value in your data set. The other kind of nice property of the mode is that it makes sense. It's intuitive sense. Well, shouldn't the center part of the distribution be the most common value? Right? That's the mode. One disadvantage is that, similar to the median, it's somewhat difficult to incorporate into other statistical models. So when you see other statistical models used, typically they will be based on the mean, less commonly on the median, but very rarely on the mode, because the mode as a measure is kind of difficult to incorporate in other statistical models. Another issue with the mode is that if you have a numerical variable that is continuous rather than discrete, the most frequent or common value, it might not be that different from other values, meaning in a continuous variable we can take on many different values rather than sort of bins of values. In a discrete numerical variable, you might have values of 1, 2, 3, and 4. So it's pretty easy to calculate the mode. But if you have a numerical variable with very minute differences, so of 1.1, 1.2, 1.3, all the way up to 1,000.1, can be the mode might only be sort of meaningless, but it might be sort of difficult to differentiate between many different modes. So in general, I would say that the mode is useful, but you don't see it as commonly as you do the mean or the median. Well, let's look at the mode of some of these variables. So the mode of the grades variables, what we're going to do is we're just going to create a little table of our values from least to most common. So in this table, the first row, those are simply the unique values of the grades variable. So students are asked to rank these 4 different attributes, grades, sports, looks, and money, and each variable has a different sort of ranking. So you can see here that 94 students ranked grades as the most important. Then 123 students ranked grades as the second most important attribute. 128 students ranked it as the 4th most important attribute, and 133 students ranked it as the 3rd most important attribute. So when you look at this sort of table of frequencies or counts, you can see that the most important sort of ranking in terms of grades, the mode is 3. Okay, so the mode of the grades variable is 3. Most students ranked grades as 3 rather than 4, 2, or 1. If we look at the next variable, the sports variable, and we look at a table of counts from least to most frequent, you can see that 47 students ranked it as the 4th most important, all the way up to 165 students who ranked sports as the most important attribute or quality for being popular. And so in that case, the mode is 1. For the looks variable, again creating a little table in which we rank the values from least to most common, the most common response is 1. So for the looks variable, 185 students said, you know, if you want to be popular, looks is the most important. And then if we look at that final column for money, and then calculating the mode by listing the values from least to most common and the corresponding counts, you can see 237 students ranked money as the 4th most important. So if we look at the mode, we can compare it with the median and the mean. So the mean, the most important quality was sports. If you look at the median, the most important quality was either looks or sports. We have a tie in that case. The 50th percentile is 2. If we look at mode, the least important is money. So the most common response for the money variable is 4. Then for grades, it's 3. For looks, it's 1. And for sports, it's 1. So we can see that across all 3 measures of central tendency, across all 3 calculations, we get a similar sort of finding, that if you want to be popular, sports and looks are really the most important attributes according to elementary school children. You might ask, okay, we have these three measures of central tendency. Which of these measures is really the best for capturing the typical observation in a numerical variable? Well, the mean is most commonly used, but if you have extreme values or outliers, then the median is usually preferred because it's robust to these extreme values. The mode is not used as often, but I think especially when you're first starting with a data set and you're trying to understand the properties of a data set, it can be very useful to calculate the mode for numerical variables, especially those that are discrete, where you have a relatively few number of unique values. In this case, 1, 2, 3, and 4. We don't have that many values for the ranking variables, so it's useful to calculate the mode. So with that, we've really uncovered the three major measures of center and location. So the mean, median, and mode. Next, we're going to talk about other measures of location, percentiles and quartiles.